Okay guys, I'm back with another video. This video, I think I should dedicate it solely to the multimeter. If you don't know how to use a multimeter, then you probably shouldn't even take a panel off of a unit without knowing how to read and use a multimeter. So, and then we're flipped around. And then so we will eventually go over a few components here. I have a relay. I have two relays. I have a single pole contactor, and I have a 10 microfarad run capacitor. But for today, well, at least right now, we are going to look at the meter. So here's my fluke. So I have voltage, AC. If you hit this button here, you'll go to direct current, but most of your direct current is only going to be on mini splits. So the majority of units you go to, you're going to have AC, which is alternating current. And then if you come here, you can read resistance and ohms. And so that'll be, you'll be using this quite a bit if you're looking for a ground, if you're popping fuses, or if you're wanting to check the windings for a compressor or a fan motor, or checking your path as well for a circuit. But yeah, so if you touch these two leads, I can't do it because I'm one-handed right now, but if you were to touch these two leads together, you'll get a beep. I don't know if you guys can hear that. But that would represent close. So this represents open. So you would have an open path, which is no good unless you're testing a contact that is normally open. So with the coil de-energized on a relay, that normally open contact should read open. But with the coil energized, then you should be reading closed. And for this situation, for a path, it doesn't matter the reading as long as you're hearing the beep and you're reading something instead of open line, which is OL, what OL stands for. So then we'll go to DC amps. Then we have temperature, and then we have capacitance, which you'll need to test your capacitors. And then last but not least, we have AC amps, which is what you'll use to, and you won't use your leads. You'll actually want to disconnect these first, and you'll use your amp clamp to clamp over a wire to read your amperage on your compressor while it's running, or your fan, one of your fan motors. So that'll give you your amperage. And on the data plate, it'll be able to tell you what it should be running at. But yeah, that is for the meter. I could really show you how to check these particular components better if I wasn't one-handed. I just started this channel, so I don't have any videos or anything. But the majority of the time, you're going to be using ohms and voltage, AC. But for this situation, let's go ahead and check this capacitor. We're going to go to capacitance. You see we're reading 0 microfarads right now. But if I put my leads on these two pods right here, we should be reading 10, and it's exactly 10. So that capacitor is good. But for an example, if it was reading 9, then it would be bad. So remember, the tolerance for that 10, a little under, a little above, should be at least 10% of 10 above 10, or minus 5% under 10. 5% of 10 under 10. And then for your relay, where's the coil? You see the coil wires right there. See that? See that little wire right there? And there's your coil, which is a load. But there's your wire, there's your wire. So here's your two coil prongs right there. So if I went between here, you should have Should be hearing a beep with my meter set to ohms. There it is. And this particular coil is ohming out at 15.1. And so on this, when this coil is energized, when you have power on this coil, and this coil, it'll tell you on the data sticker right here, is a 24 volt coil. So if you energize 24 volts, and it doesn't matter, guys, the coil doesn't care if you put the 24 volt here and common here, or 24 volt here and common here. The coil does not care. But anyway, once this coil is energized, any contact, let's see which contact is normally open. 1 to 3 is normally open. I don't know if you guys can see that on there. Once that coil is energized, that normally open contact will close. And vice versa, 1 to 2. 1 and 2 contact is normally closed. So once that coil is energized, 1 and 2 will open. And 1 and 3 will close. And 4 and 6 will close. And 4 and 5 will open. So that is a relay. And this is a contactor. Single pole contactor. You see we have a jumper for L2. L1 we have an actual contact. And the way that guy makes and passes L1 leg is when this coil is energized, it will create a magnetic field and pull that contact in and pass L1 leg of power for your fan motor and your compressor. But yep, that's just a little coil right there. And the contactor measures at, one sec, measures, this contactor coil is measuring 18.3 ohms. I think typical for a brand new contactor. This one's slightly used, but it's good. A normal brand new contactor coil, if you check with your meter on ohms, will read around 16 ohms. I'm pretty sure. But anyway, here's another relay. I won't go over that one because it's the same as, pretty much the same concept. You always are going to have a coil for a contactor or a relay, and for your capacitor, you're going to have microfarads. And so yeah, I just wanted to brief y'all on that. I know I'm not the best teacher, but I'm trying to do the best I can here. I am gonna have to definitely get another camera so I can be hands-free and really be able to show you well. But yeah, that is the first lesson, is the meter. If you do not know how to use it, you can't do anything. Thanks guys for watching. I'll try to update my camera situation so I can show you more hands-on. Look forward to seeing you.